Good morning students. Today our lesson superconductivity. Already previous videos you know what is superconductivity, what are the superconductors. Okay. Generally superconductors are bad conductors. When temperature decreases at particular temperature they shows zero resistivity. That means infinity conductivity. That phenomena is called the superconductivity. Those materials are called superconductors. That means at a particular temperature those are become superconductors. That particular temperature is called critical temperature. Already you know what is critical temperature. Okay. Below critical temperature those are superconductors. Above critical temperature those are normal conductors. How it is possible? Why they show superconductivity below the critical temperature? What happens at that critical temperature is explained by the theory BCS theory. Today our topic BCS theory. Okay. BCS theory formulated by three scientists. Those are John Bardeen, Leon Cooper, Robert Schrieffer. Bardeen, Cooper, Schrieffer. Those three scientists in 1972 proved this theory BCS theory. These three scientists, that's why this theory BCS theory. Okay. In this, according to this theory, an electron approaches a positive ion core in the crystal. An electron approaches a positive ion core in the crystal. Then the electron makes an attraction with a positive ion. That electron, which electron approaches positive ion core? That electron attracted by the positive ion. This attraction sets in motion the positive ion, and this ion motion disturbs the lattice. This ion motion disturbs the lattice. In this, first electron attracted by the positive ion, due to this attraction this positive ion core distorts. Due to this attraction positive ion, the motion disturbs the lattice. Okay. This distortion of lattice, the disturbance in the lattice, quantized in terms of phonons. This distortion of lattice quantized in terms of phonon. Okay. Suppose you take an electron having energy E approaches a positive ion core. You take an electron having the energy E approaches a positive ion core. Here it suffers attractive Coulomb interaction. It will lose its energy to K energy to ion core. This electron loses energy and it suffers a loss of energy K. Okay. Thus the energy of electron will become E minus K. Thus the energy of the electron will be E minus K. Due to this attraction ion core is set in motion and thus distorts the lattice. Due to this attraction, ion core is set in motion and thus distorts the lattice. Okay. At the time of distortion of lattice, that means at a positive ion, if another electron approaches the distorted lattice, then the interaction between them takes place. At the time of distortion, another electron approaches the lattice. Interaction between them takes place. This interaction lowers the energy of the second electron. This interaction lowers the energy of second electron. Now the two electrons interact through the phonon field. Now the two electrons interact through the phonon field and results in the lowering of energy of the electron. Thus, there is exchange of virtual energy. That means here this ion gives the energy to another electron. So, the energy transfer from one electron to another electron, that is a virtual energy. That energy is called, virtual energy is called phonon, phonon energy. This phonon energy between two electrons exchange that phonon energy between two electrons in this crystal. Okay. Now the two electrons interacts through the phonon field and results in the lowering of energy of the electron. The two electrons interacts through the phonon field. Generally, electrons are repelled by Coulomb force. But those electrons paired with electron lattice electron interaction or electron phonon field electron interaction. Okay, this attractive interaction is larger. That attraction interaction, generally electrons have repulsive force, but in this theory those explain those two electrons which are bounded with the phonon field, those takes attraction and forms a electron pair. Okay, those electrons, if those attractive, this attractive interaction is larger, that attraction between two electrons larger when two electrons have opposite spin and momenta. Opposite spin and momenta. Cooper pairs. Here those side electrons are paired up. Those electrons are called Cooper pairs. Those electrons, which electrons are paired, those are having opposite spin and momenta, which interact attractively in the phonon field, are called Cooper pairs. In phonon field, two electrons we called attractively interacted. Those electrons are called the Cooper pairs. Below the critical temperature, electron lattice electron interaction is stronger than electron Coulomb interaction. That's why they are paired up. Generally, two electrons are not paired up because having same charge, negative charges. Two repulsive, those two repulsive. In between those two electrons having repulsive force. But below the critical temperature, those repulsive force overtake that electron lattice electron interaction is stronger, overtake that repulsive force. That's why those two electrons tend to pair up. The pairing is complete at 0 Kelvin. From critical temperature to, we decrease the temperature from critical temperature to decrease the temperature up to 0 Kelvin, the pairing is completed and is completely broken at critical temperature. That means you increase the temperature from 0 Kelvin at critical temperature at up to critical temperature, those electrons paired up. After the critical temperature, the pairing electrons become a free electrons. Okay, free electrons. That's why that superconductor become a normal conductor. Okay, what is energy gap in superconductors? Energy gap is the energy difference between the free state of the electron, that means normal conducting state, and its paired state, that means superconducting state. Energy gap is the energy difference between the free state of the electron, that means the normal state, and its paired state, that means superconducting state. Okay, that is the energy gap. That energy gap is maximum at 0 Kelvin because pairing is complete. Energy gap is minimum at critical temperature because pairing is dissolved. Energy gap is minimum at critical temperature because pairing is dissolved. Okay, this is about the energy gap in superconductors. Next, coherent length. What is coherent length? The paired electrons are not scattered because they smoothly ride over the lattice imperfections. The paired electrons, if you take a single electron, that electron scattered by the imperfections of the lattice, defects, imperfections. But when they paired, that means two electrons paired, those are not scattered, they are smoothly ride over that defects also. That's why they show the high conductivity. The superconductivity is due to superconductivity is due to mutual interaction and correlation of electrons over a considerable distance called coherent. Superconductivity is due to mutual interaction and correlation of electrons over a considerable distance. That superconductivity shows, that means the pairing of electron is possible up to a certain distance. The distance is called the coherent length. Coherent length. The ratio of penetration depth and coherent length is called K. If the K value is less than 1 by root 2, the superconductors are type 1 superconductors. Already you know what is type 1, type 2 superconductors. When we said that is the type 1 superconductor, the ratio of lambda by epsilon naught is less than 1 by root 2, the superconductors are type 1 superconductors. If K value greater than 1 by root 2, the superconductors are type 2 superconductors. Okay. These are the Cooper pairs which are interacted with phonon energy. Those electrons are called Cooper pairs. Those electrons which have opposite spin and momenta. Those are the Cooper pairs, very important for 2 marks Cooper pairs. This is the 10 marks question, BCS theory, very important question. Okay. Thank you.